Right, so another OMG additional chemistry. Today we are talking about metals and where they come from and how we find metals and then what their uses are. So all metals are extracted from something, an ore, okay? So extracted from ores, these are minerals that are found in the Earth's crust, okay? So the Earth's crust is the top bit, the bit that we stand on, the bit that we live on, and all our metals are extracted from ores, okay? Ores tends to mean that they're attached to oxygen or sulfur. It could be a couple other things, but they tend to be the main things they're attached to, okay? This method used to extract metal depends on the stability of its compound in the ore, okay, which in turn kind of tells you the reactivity. So if an element's more reactive than carbon, such as aluminium, is extracted by electrolysis, less reactive than carbon, such as iron, is extracted by the reduction of carbon. So it depends how reactive your element is, or the element you want to get out, depends on how easy it is to extract. Stuff like gold, silver, bottom end ones, really unreactive metals, they tend to actually be found not really in ores but just in the Earth's crust independently, called the metal displacements. This is how we might get some metals out. So the more reactive metal will displace the less reactive metal, okay? More reactive metals have a greater tendency to lose electrons and form positive ions, okay? So if you're higher up the reactivity series, you will be more reactive and more likely to displace another element. So in this case, we've got magnesium plus copper sulfate. So copper, because copper is less reactive than magnesium, copper's by here, magnesium's by here. So because they're less reactive, copper's less reactive than magnesium. Magnesium essentially steals the sulfate away, and then it becomes copper on its own plus magnesium sulfate. So the higher up you are, the more reactive you are, the more likely you are to steal whatever it's bonded to. This is quite a nice way if we wanted to get copper on its own though, to make pipes and stuff, wiring. So copper's technically on its own now, so we can use that for its properties. Sometimes they might ask you to write like ionic equations, okay? So metals, unless they say metals tend to be independent, they don't need any subscripts, and then obviously you'd use crisscross method to work that out. Extracting iron is one of the things that you need to be able to do, okay? Iron is extracted in a little bit of a strange way, okay? Well, it's not strange, but it's a bit of a detailed way that you need to know. So iron is extracted from its ore in a huge container known as the blast furnace, okay? And we have blast furnace down the docks way in Cardiff, so we're not unfamiliar with them, okay? The main iron ore that we use is something called iron oxide or hematite, okay? And what we need to do is remove that oxygen. So we want iron on its own. It's got loads of properties, building bridges, cast iron, etc. So we want to make sure that we can get that iron on its own, okay? So what we do first is we pump in three things: iron ore, coke and limestone, okay? The coke's a fuel, it's a source of carbon. Iron ore is obviously the iron attached to oxygen, and limestone is used then to remove impurities. As you can see, it's much colder at the top. It's a bit of a strange situation because normally hot air rises, but because the hot air is blasted in down here. So the hot air is blasted in down here. That's what makes that so warm down here. So hot air reacts with the coke. So the hot air comes in down the bottom here. The coke comes in down the top. They kind of meet in the middle and react to form carbon dioxide and heat energy. That's why it's so warm down the bottom, because they're reacting down here to make heat energy, okay? We then add more coke. The more coke we make, reduces the carbon dioxide to carbon monoxide, okay? Carbon monoxide acts as a reducing agent to reduce the iron oxide. So carbon, technically higher up the reactivity series than iron, so it will take whatever it wants from iron, in this case the oxide. So instead of just having one oxygen, it goes back to having two oxygens, okay? Limestone then, like I said, removes the impurities. Only time you're ever allowed to say this word, slag. Slag is then used to make tarmac and stuff, so it's actually quite a useful tool for us. And then molten iron, so iron that's been melted and there's a little tap to extract it, and then we use that iron to whatever we want to use it for. So exactly the same things now. Pause the video, have a go at questions, and then we'll see at the end. So what is an ore? An ore is a metal attached to something else, often oxygen, or it might potentially be sulfur, okay? Where do we find ores? In the Earth's crust. That kind of depends. It could be a displacement, often displacement, but it'll depend on whether it needs to be displaced with carbon, or we need to use something like a higher metal, so a higher metal up in the reactivity series. What is displacement? More reactive metal displaces the less reactive metal. Okay, what reacts with coke? Hot oxygen. What is the use of limestone? To remove impurities. So if you got them all right, that's great. You can move on to the next video. If you didn't get them right, please stop, go back, watch the video again and try the questions again until we're getting them all right. It's really good practice, a really good revision technique.